Today we will begin our unit on equations. Please copy down the standard benchmark indicator on a clean page in your math notebook. The student will model and solve algebraic equations. Wow, words of wisdom. Expression, a mathematical phrase that combines operations, numbers, and variables. For example, x plus 5 or 4n minus 6. Coefficient, a number that multiplies a variable. For example, the 3 in 3x, which also means 3 times x. Equation, a statement that two mathematical expressions are equal. Example, 50 plus n equals 75. A term is any number, variable, product, or quotient in an expression. For example, it could be 6x, it could be 5x, it could be 3. Any of those are terms. Variable, a letter or symbol representing some number. We don't know what it is until we work through the equation or the expression. For example, 10 plus n is our variable. A constant is a number that does not change. For example, the 5 and 5 plus x and the 12 and 5 plus x equals 12. Variables and expressions. A variable is a quantity that can change or vary. Mathematicians use letters to represent variables. A quantity that does not change is a constant. An expression is a mathematical phrase involving constants, variables, and operation symbols. There are different ways to represent different operations. 4 examples are shown below. Addition, x plus 6, x is a variable and 6 is a constant. Subtraction, 91 minus x is a variable, 91 is a constant. Multiplication can be written as 3x or 3 times x. When it's written with just a number and the variable next to it, it means multiplication. You're multiplying the number times whatever the variable ends up being. That is the way you're going to see it most of the time. They start to not use the x for multiplication as you get on in math because x becomes our major variable that we use as we get further on into algebra. So in this one, x is a variable, 3 is the constant. Then for division, you can do 12 divided by x written out, or you can do it as a fraction. It's still read 12 divided by x. X is still the variable, 12 is the constant. If you know the values of the variable, you can evaluate the expression by replacing the variable with each value. This is known as substituting a value for the variable. Example, evaluate 2x for x equals 4, 6, and 8. So 2x means 2 times x. To evaluate the expression, you need to substitute a value for x. When x equals 4, we substitute 4 for the x. You can make a table to evaluate the expression for multiples of x. So if you look to the right at our table, they've given us the 3 variables that we're using, the values we're using for x here. So we're doing 2 times 4. This is the first one, that equals 8. Then we plug in 6. We get 2 times 6 is 12. Then we plug in 2 times 8 is 16. So depending on what the variable equals, so in this case, we're evaluating for 3 different numbers. We're going to get 3 different answers for this one because it's an expression. So when 2x equals 8, x is 4. When 2x equals 12, it means x was 6. And when 2x equals 16, it meant x was 8. For the triad, we're going to evaluate x plus 12 for x equals 2, 5, and 10. So for A, we substitute 2 for x. So we have 2 plus 12 equals 14. For B, we're substituting 5 for x, so we have 5 plus 12 is 17. Then for C, we have 10 for x, so we get to solve that, and we have 10 plus 12 equals 22. So for each one of these expressions, we're going to evaluate them for 2, 5, and 10. So we're going to have 3 answers for each one. So for D, we have 6x, which means 6 times x. So we're going to plug in 2. 6 times 2 is 12. 6 times 5 is 30. And 6 times 10 is 60. For E, we have x minus 1, so we're going to plug in the same 3 numbers. So 2 minus 1 is 1. 5 minus 1 is 4. And 10 minus 1 is 9. For f, we have 50 divided by x, so 50 divided by 2 is 25. 50 divided by 5 is 10. And 50 divided by 10 is 5. For g, we have 27 plus x. So 27 plus 2 is 29. 27 plus 5 is 32. And 27 plus 10 is 37. For h, we have 16 minus x, so 16 minus 2 is 14. 16 minus 5 is 11. And 16 minus 10 is 6. For I, we have 100 divided by x. So 100 divided by 2 is 50. 100 divided by 5 is 20. And 100 divided by 10 is 10. The second page here, writing expressions. Some words in English can be translated into specific mathematical operations. So we have sum, which is the result of adding numbers. So for example, 7 plus 2 or 8 plus x. Difference, the result of subtracting numbers, 12 minus 3 or 28 minus y. Product, the result of multiplying numbers, 4 times 16 or 8 times c. And quotient, the result of dividing numbers, such as 81 divided by 9 or 14 divided by s. To translate situations that don't use these words, you need to choose an operation that is appropriate for the situation. It may be easier to choose an operation if you first replace the variable with a number. Example, write an expression to answer. What is the quotient of 99 divided by x? So step 1, what operation is being done? A quotient is the answer when dividing, so use division to write the expression. Step 2, use the appropriate sign to write the expression. 99 divided by x, or as a fraction. Same way, it's just as a fraction form, so 99 divided by x again. So these expressions show the quotient of 99 divided by x. You're not actually solving these, we're just writing the expressions so that if we were given a number to plug in, we could find an answer. Try it. Write an expression. What is 12 minus r? So for A, what is the operation being done? We know minus is subtraction. And then for B, we need to write the expression. So 12, a minus sign, and an r. Write an expression to answer each question. For C, what is 32 times as big as y? So we know times is multiplication, so our expression is going to be written as 32y. We don't need the x in for the multiplication symbol because when you put a number next to a variable, it means you're multiplying the two. For D, what is 24 more than n? We know more than is addition, so we're going to do 24 plus n. For E, we have what is 11 less than B? So we know we're subtracting, and we want 11 less than B. So B is going to have to be first, so it's going to be B minus 11. F, what is D divided by 5? So we can write that out as D division sign 5, or D and then the fraction bar and the 5. Either one is acceptable. For G, we have what is G plus 10. We know plus is addition, so we'll write G, the addition sign, 10. For H, Brian has P pencils and bought 4 more. How many does he have? We need to write an expression. So for P as our variable, he got 4 more, so we know we're adding. So it's going to be P plus 4. For I, Tammy plants 6 rows of T tomato plants each, meaning we don't know how many she planted in a row. It's just that variable, so we're going to use a lowercase t for it. So how many tomato plants did she plant? So we're going to do 6 times t, so we're just going to write it as 6t. And it's important to remember that anytime you're working with variables, they are lowercase numbers in algebra. So make sure all your letters are lowercase as we work through this unit. Please make sure you have all of your work copied down and then glue both pages in your math notebook.